Okay guys, so believe it or not, I actually am doing this for a second time because YouTube would not upload my video. They said it was too long. Imagine that. All right, so I'm going to try and make this shorter. So if I'm going too fast, remember you can just pause and then you can come back to the video when you're ready. So we left off here today, and what we want to do is kind of explore that little pinkish, this upper left hand bubble. Okay, so we're going to start talking about some of these during this unit. And to do that, we first have to look at undefined terms. What are undefined terms? Well, I have this little comic, and I will let you pause and read that rather than spending time looking at it. But it kind of is a comic related to circular logic or circular definitions. And it's important that we learn how to do all of our, to make all of our definitions non-circular so that we don't have that type of problem. Okay, so our basic undefined terms are point, line, and plane. We attempt to describe them, but it's not a true definition. That's why we call them undefined. Points are the basic unit of geometry. They do not have an actual size, just a location. If you think about where two edges of something meet, that's a location. There's not really a point there, but we represent our points using dots, labeled with capital letters, and we never name the same two points with the same letter in the same sketch. Okay, very important there. You might have an A and A prime when we do transformations, but we wouldn't have duplicate A's in the same sketch. Lines. Lines are, I don't know why my thing's not working here. I have to use this, I guess. Lines extend indefinitely and have no thickness or width. There are an infinite number of points on a line, which is why we use arrows. And there you go, how to sketch using arrows at both ends. That represents indefinitely and infinite. We can name them two ways, a small script letter or any 2 points on the line. So as you can see, there are an infinite number of points on the line. I can pick any two, I can put them in any order, and because they are indefinite, I can represent that with the little line on top representing the arrows, okay? Never name a line using 3 points, and you'll see why momentarily. Lines can be intersecting, parallel. Parallel means they are coplanar, but not intersecting. So they do lie on the same plane versus skew, which are also non-intersecting, but do not lie on the same plane. So if you think of the edge of your countertop and a line that goes vertically up and down that might not intersect that line on the countertop, they are skew lines. Our next unit is actually about lines, so we'll work more with those later. But it's important that you have the distinction between the skew. Collinear points. Collinear points are points that lie on the same line, and the line does not have to be visible. So if I could draw a line through the points, then they are collinear. A point lies on a plane. This is review from last year if the coordinates of the point satisfy the equation representing the line. So to find if A is on the line represented by y equals negative 3x plus 3, you would plug it in, and if the solution is valid, then the point lies on the plane. Okay, and if you look at this diagram down here, I cannot in no way draw a line through A, B, and C. Okay. Planes. Alrighty, planes are length and width but no thickness, so it's a surface kind of, a flat surface that extends in all directions. We sketch it using a parallelogram, and we name it 2 ways, either with a capital script letter or with any 3 non-collinear points in the plane. Okay, so if you look at that green sketch, if I had C, A, and a point D out here, that point D might be collinear with C and A. So I can't use that to represent the plane because it doesn't really define where the plane is, if you think about that for a little bit. different planes in the same figure. So they can be obvious, such as A, B, C, D. They can, and it's going to give you a number of other ones here. And these are pretty obvious planes that lie in this figure. And what you'll see is that the planes aren't always the obvious ones. Those are pretty much our obvious planes. Top, bottom, left side, right side, front, back. Okay. ABFE is kind of like the back, and CGHD. And notice that they are named sequentially, consecutively in order. We cannot call this plane that's to the right BGFC. It doesn't make sense. You have to kind of go around a figure in order. Okay. BCG, you could call it. You don't have to name it with the fourth letter. And this will show you some other planes that might be diagonal through that figure. They might not be noticeable. A, F, G, D. So A, F, G, D is kind of like a diagonal plane through there, a little bit of a cross section, okay? So you don't have to, it doesn't have to be obvious. If you can draw a plane through there, then a plane exists, okay? ACH and AGF. Coplanar objects are objects that lie on the same plane. The plane does not have to be visible. This is what I was just saying. So if I look at A, B, and C, they're on the same plane, yes. A, B, C, and F. I think I would have a hard time getting one flat surface to go through those 4 points. So we would say those are non-coplanar. HGFE, HGFE, sure, that one's fine, okay? EHCB would also be yes. All right, so that's the kind of coplanar idea. A, G, and F, yes. Any 3 points do form a plane, like any 2 points form a line. CBFH, CBFH, oops, H is way over there. Sorry, can't put a plane through that. Other important terms you're going to need to know. We will probably be looking at these later in the course. For now, just try to accept them. Array, the definition. Now, our definitions in math are somewhat strong. We try to make them so there is no other possibility that could exist. So if you think about the definition, RA is the segment RA and all points Y such that A is between, and we're going to talk about this betweenness tomorrow, but all points Y such that A is between R and Y. Okay, so Y is somewhere out here such that A is between R and that Y. Okay, and it is important how we name array because we want the arrow to be going in the correct direction. Opposite rays. This is kind of an abstract definition. Again, you really have to think about what it's saying, and betweenness we haven't talked about, so just kind of use your intuitive definition of betweenness for now. If A is between X and Y, AX and AY are opposite rays. So they must have the same kind of starting point or end point, and this fails the definition of betweenness, which you'll see later. And it's a good thing because we use betweenness in this definition, and this is actually, these are not opposite rays, so it's betweenness that fails there. And here, there's an overlapping section. If you look at DE and ED, those rays have this overlapping section in the middle, so they are not, in fact, opposite rays. A line segment. The definition is part of a line that consists of 2 points called the endpoints and all points between them. You sketch it with 2 points and a line segment between, and you name it with that little segment on top. Important to distinguish between if it's a segment, a line, or a ray when you're writing that. Okay, so the details do matter, unfortunately. And again, we talked about this a little bit. If you write it without the symbol, we're talking about the length. Angle and points, and a lot of this is also review. An angle is a figure formed by 2 rays with a common endpoint called the vertex. The common rays form the sides of the angle. Their intersection is the vertex. An angle can have points in the interior, exterior, or on the angle, as A, B, and C are. Okay, D is in the interior, E is in the exterior, points A, B, and C are on the angle. Naming an angle, very important. You will most always use 3 points. You can use 1 point or 1 letter, we'll see when, or you can use a number. Okay, the vertex has to be the middle letter. There is no ACB in this. We can use 1 point, the vertex letter, angle B. This is only allowed when it is unambiguous, and we'll talk about that case, and you've probably heard me talk about it before. You can also have a number in there, and there are cases where diagrams are kind of confusing and the numbers come in very handy. Obviously, that's not the degrees, okay? We cannot use 1 letter when more than 1 angle has the same vertex, such as this case here. There is no angle K. There's no such thing, and you will get marked off if you call that angle K because it does not exist. Okay, you have to be specific. Also, there's no angle 5. Okay, you can't add the 2 and 3 together. You would have to call that angle either LKP or PKL if I was talking about the large angle. Okay, so a little bit on naming angles. This is very much review, so I'm going to go through it really quick to save time. Angles are measured in degrees. A circle is 360, a semicircle is 180, and a quarter circle is 90. Okay. One degree is 100/360th of a circle. 4 types of angles. This is also review, so I'm just going to throw it up there and you can write those down. Pause and write them down. Congruent. We talked about this before. It means same size and shape, and we have the little tilde over the equal sign. Okay? And it's got to catch up to me here. I'm clicking too fast. There we go. Okay, congruent angles are angles that have the same measure. They're marked with the same number of arcs. Angle 3 is congruent to angle 5, and we'll do a lot with notation later. Midpoint is a very important definition. We will be using this a lot. Probably 60% of your proofs this year will use the definition of a midpoint. A point that divides a segment into 2 congruent segments, and that is the definition. Okay, so if you know it's the midpoint, then you know the segments are congruent. If you know the segments are congruent, then it is the midpoint. We are done. Thank you for your attention. Please go back and fill in any definitions you didn't get, and I will see you tomorrow.